Often while studying, I find myself in need of a good cup of coffee. But as I wait for the machine to heat up, I can't help but wonder, how does a Keurig make coffee? More specifically, how does the cold water I put in the reservoir heat up so fast? What's going on the inside of the machine? With so many questions yet so few answers, I decided to take a closer look. Surprisingly, it's actually a fairly simple system of air and water pumps that move the water from the water reservoir in the back through the heater in the machine and out the K-cup at the top, resulting in delicious hot coffee in your mug. Let's start from the beginning. When you plug the Keurig into a power source, two things happen. The LCD screen turns on, and a 12-volt signal is applied to two internal solenoid valves, opening them. The forward solenoid valve controls the water pump, while the aft solenoid valve controls the air pump. These valves are the driving forces behind how the Keurig is able to transform electricity into coffee. By pressing the on button on the LCD screen, the electricity is removed from the forward solenoid valve, closing it, and instead applied to the water pump, causing it to turn on. Due to water pressure, the spring-loaded check valve opens and allows water to flow in from the reservoir to the water heater, but not vice versa. The water pump is turned off when the water level reaches the height of the minimum cup probe. This is done by redirecting the electrical signal once more and reopening the forward solenoid valve. The water heater then heats and maintains the water at 192 degrees Fahrenheit. The LCD screen indicating ready to brew once that entire process is complete. So all of that happens while the Keurig is simply preheating. So what happens when it's actually brewing? After placing the desired K-cup in the machine and hitting the brew button, depending on the volume of coffee you request, more water may be pumped out of the reservoir in the same manner as before. Regardless of whether more water is being heated or not, however, both the forward and aft solenoid valves are closed, which means both the water and air pumps are on. The air pump forces air in through the top of the water heater, which in turn causes hot water to be forced out and into the K-cup. So that's pretty much how a Keurig makes coffee. After you have your coffee in hand, make sure to turn off your machine and not waste energy. Speaking of energy, I was curious how much energy a Keurig actually uses. Using a kilowatt, I found it used an average of 1,290 watts to warm up, which took about 2 minutes. So 1,290 watts times 120 seconds equals 154,800 joules. I found it used an average of 135 watts to brew a cup of coffee, which took only 1 minute. So 135 watts times 60 seconds equals 8,100 joules.